So even odd properties of trigonometric functions is not the hardest thing in the world. It seems really weird. It looks a little bit like this. We say that sine of negative theta is actually the opposite of sine theta. Cosine of negative theta is equal to, well, cosine of theta. And lastly, I'm only going to do these three because the rest of them should make sense on their own. Tan of negative theta is equal to negative, or the opposite of tan of theta. And if you don't mind, the way I'm going to demonstrate to you is this. I'm going to use, I think that I'm going to use, I don't know, 30 degrees. So I'm going to take, here's my initial ray right here. And I'm going to open it up to 30 degrees. So there's 30 degrees, if you don't mind. So what I did was I took this initial ray and I opened it this way, right, to get a positive angular value. I opened it this way. And now what I'm suggesting to you is that I'm going to open up this second angular value with the same initial ray. This is an angle in standard position. And I'm going to open it to here. And what I'm going to suggest to you further than that is that this angle is positive 30 degrees, and that this angle down here is negative 30 degrees. So look at this just for a second. It is this straightforward and this simple. That sine, this is what it says, sine of negative theta. So sine of negative 30 degrees is the opposite of sine of 30 degrees. It says here that sine of negative 30 degrees is the opposite of sine of 30 degrees. And isn't that true? So let me have a second. So let's kind of test that idea out and see if that's true. That sine of negative 30 degrees is the opposite of sine of 30 degrees. Well, sine is this value right here. Let's take a look here. Sine is this value, is the second value, right? So sine of 30 degrees is 1/2. Sine of negative 30 degrees is opposite 1/2. So it is true, isn't it? And that's all that says. When we look at the second, when we go to cosine, it says that cosine of negative theta is equal to the same is the same as cosine of theta. Well, let's test that out a little bit and see if that isn't true. So I'm going to just put that in and say that if that's true, then cosine of negative 30 degrees should be the same as cosine of 30 degrees. That's what that says, right? So we go and we test that, and we go to negative 30 degrees, and we say, well, the cosine value of negative 30 degrees, is square root 3 over 2. And when we go to positive 30 degrees, it's square root 3 over 2. And it makes perfect sense to me, because if you went from 30 degrees to negative 30 degrees, the value of x never changed, right? They're right underneath of each other. So that's why that changes. That's why that doesn't change. Why the two values do change is that these heights are opposite heights. This height, this height, and this one are perfect opposite heights. So now I'm looking at this. This one I'm judging the move in x, but let this blue line be the judging the height. The height of this line is this much. The height of this one is the exact opposite, isn't it? So the height of this blue line is 1/2. If this one is the exact opposite of that, it's negative 1/2. This makes perfect sense to me, and I think that people struggle with it for no good reason. I'm not calling anybody smart or dumb. I'm just saying that I think it fundamentally makes pretty good sense, where somehow or another a lot of teachers and professors seem to get it a little bit, I don't know, convoluted. And hopefully you can see why this is true, because we remember that tan is equal to sine theta over cosine theta. And here you're going to have opposite over same. So it's going to be opposite, isn't it? So hopefully this helped you. If you haven't already subscribed, please subscribe to me, and your comments are always welcome. Thanks so much.